This is lesson 3.3 for Secondary 2 Honors Math, Tangents to Circles. So just to warm up for this lesson, we are going to need some skills that we've had before. So do you remember how to multiply two binomials? So I want you to pause the video, I want you to do these three questions and then come back and let's just make sure you remember. So remember distributive property, so x times x is x squared, negative 2x plus 7x, and then minus 14, and you're going to combine your like terms. And so that's my product. The second one, 2x squared minus 8x minus 5x plus 20. So combining like terms, I'm going to get 2x squared minus 13x plus 20. Okay, this third one, this is the one where people mess up a lot, and you need to make sure you've got this one. Remember that there's no shortcuts on this. The wrong thing that people do here is they'll say 4x squared is 16x squared, and 3 squared is 9, and so that's their answer, and that is wrong. Remember that when you do this, you're talking about 4x plus 3 times 4x plus 3. And you need to write that out. Remember that there's no shortcuts to that. So you're going to say 4x times 4x is 16x squared. 4x times 3 is 12x plus 12x plus 9. So you've still got the 16x squared and the plus 9, but you've got the 24x in the middle, and that's important. So multiplying polynomials is going to be important in this lesson. Okay, we talked earlier, a couple lessons ago, about a tangent line. And so a tangent line is a line that intersects a circle at exactly, so exactly means not more, but exactly one point. And the point of tangency is the point where a tangent line intersects a circle. So those are two words that you need to know what they mean. Okay, I want you now to get a straight edge, and we're going to just draw some tangent lines. So this one to the right, it says a tangent line and showing a point of tangency. So we're just going to draw a line. Yours will look better than mine because I don't have a straight edge that I can use on this, but that's going to be my point of tangency. There is a special property that we have with tangent lines and circles, and so I want you to discover that. So what I want you to do is I want you to take these 5 circles, and I want you to draw a tangent line anywhere on the circle. So of course it can't be like that, that's not a tangent line. But just draw 5 different situations where you have a tangent line. So go ahead and do that. Okay, so here's my 5 tangent lines that I drew. Step 2, it says draw a radius from the center to the point of tangency. So if we do that on each circle, what do you notice about the line that is tangent and the radius? Do you notice something that always looks to be the case? Okay, hopefully you noticed it. And what it is that the tangent line, or the tangent line to a circle, and the radius are always perpendicular. And so that means that they're 90 degrees, obviously, and that's going to help us find different parts that we're going to be looking for, because the perpendicular part is something that's going to be very helpful. Okay, so let's do some practice problems. First of all, we're going to determine if line AB is tangent to the circle. So how do I tell? Well, if it's tangent, this has to be a 90-degree angle. If that's a 90-degree angle, then it makes this triangle a right triangle. If it is a right triangle, then the Pythagorean theorem has to work. And so I can use what I've got. So this right here is 4, so that would mean this is 4. So if I use my Pythagorean theorem, I'm going to say 6 squared plus 8 squared. 8 squared equals 10 squared, so that's 36 plus 64. Is that equal to 100? It is, so the answer is yes, AB is tangent to circle, no, it doesn't have a name, to the circle. Okay, the next problem, we're going to see if AB is tangent to the circle, and if it is, it has to be perpendicular right there. So we need to find our measurements there. We've got 7.2 as the radius, so that means that 7.2 is the radius right there. The 9.8 is just referring to that, and I can tell because of the placement of the 9.8. And so what I'm going to do is I'm going to see if 7.2 squared plus 15.4 squared is equal to 7.2 plus 9.8 squared. So put that in your calculator, see if that's true. I get 289 equals 289, and that is true, and so yes, this is a tangent. Okay, number 3. Looking at your picture, this is 10.2, so this has to be 10.2 right there. So you have to look for things that you're told without it being very blatant, so make sure you're watching for that. So I'm going to have the 10.2 squared plus 13.3 squared. Question, is that equal to, this is 17 squared. 17. So see if that's equal. Okay, with the decimals, it's about 281 on the left-hand side and 289 on the right-hand side. And so since that is not equal, AB is not tangent. Oops, I forgot to answer those questions, so we're just going to see what we did just do is we just see if the tangent is perpendicular to the radius. Okay, let's do some more. Okay, in these problems we're going to be solving for an unknown, so I don't know how long that side is, but it says that assume lines that which appear to be tangent are tangent. So we're going to treat this as a tangent line, which means this is going to be 90 degrees, which means I'm going to use my Pythagorean theorem. So I'm going to say n squared plus 12 squared is equal to 20 squared. So that is, this is where my square numbers come in handy to know them. So n squared is equal to 266, 256. Okay, so then that means that n is equal to 16 because the square root of 256 is 16. Okay, number 5, we're going to say 8.4 squared plus 11.2 squared. Oops, 11.2 squared is equal to, this is 8.4 right here. This is equal to 8.4 plus n squared. This is why we did the warm-up questions, because you're going to have to use your multiplying polynomials to do this. Okay, when you do the left-hand side, that's going to come out to be 196. On the other side, I'm going to leave it as 8.4 plus n quantity squared, and since I'm trying to solve for n, I need to get rid of that square right there. I need to get the n by itself, so I'm going to take the square root of that. If I have the square root of something squared, it's just that thing. So when I take the square root of that, it's just going to be 8.4 plus n, and I take the square root of the other side, and it's 14, and so then that helps me to be able to solve that pretty easily. So 14 minus 8.4 is 5.6, and so that is the length of this piece right there. Okay, and number 6, I'm going to say n squared plus 8 squared is equal to 17 squared. So n squared plus 8 squared is equal to 289. The 8 squared, of course, is 64. So n squared is equal to 289 minus 64, which is 225. And since I know my square numbers quickly, I know that that's equal to 15. Okay, in this next section, it says solve for x. Assume that lines which appear to be tangent are tangent. So that just means that this looks like it's tangent, so we're going to say that it is. Okay, so kind of that's part of the limitation of the way that we can draw. If I would put a 90-degree angle, then you would have known for a fact. But this is going to be a common set of directions because the limitations of drawing this on a computer. So in number 7, to find what x is, so what that length right there is, you'll notice that that's part of a right triangle that's formed. And so I can use Pythagorean theorem to help me find the answer to this question. So I know that x squared, which is the one leg, so this right here, plus 16 squared, that's the other leg, is equal to x plus 8 quantity squared. Now when you do that part, this is why we reviewed it at the beginning, remember that that is not x squared plus 64. So x squared plus 256 is equal to the x plus 8, I'll just write it over here, quantity squared. You have to make sure you remember that that's x squared plus 8x plus 8x, so plus 16x plus 64. So you've got to remember that that's not just x squared plus 64. That's probably one of the most common mistakes that people will make on this one. Okay, you need to simplify that because you're trying to solve for x. So the next thing I'm going to do is I'm going to subtract x squared from both sides. And so I'm going to have 256 equals 16x plus 64. So I'll subtract 64 from both sides. And I get 16x is equal to 192. And I'm going to divide that by 16 on both sides, and I get x is equal to 12. So that's the answer to that question. The radius of this circle is 12. And so this hypotenuse right there is 12 plus 8, so that's 20. So 16 squared plus 12 squared should be equal to 20 squared. If it's not, then we did something wrong. Okay, I want you to pause the video and I want you to try the next two, number 8 and 9. So just make sure that you understand how to set that up and how to solve for x. Okay, on number 8, did you get this side of the equation right? Did you make sure that you didn't say it was x squared plus 36? Got to make sure about that. Okay, so we get down to the end of solving this and we get that x is equal to 9. And so the radius of this circle is 9. Okay, number 9. Again, make sure that you got this side of the equation right, because if you get that wrong, you're going to get the whole thing wrong. And then solving, I subtracted the x squared from both sides, and then I subtracted 25 from both sides, and you end up with x equals 9.6. Now, to me, that seemed kind of different because I haven't had something like that before. So I did put it through the Pythagorean theorem to check. So I did do 9.6 squared plus 11 squared, and then I made sure that that was equal to 9.6 plus 5 quantity squared. So I made sure that that was true, and it is. So I just wanted to make sure because it was weird. Okay, I'll continue the second part of the lesson in the next video.